welcome back. Today we're going to talk about solving polynomials, and it's just going to be a few examples. Our essential question is, how do we solve a polynomial equation, and what are the different methods? And the first thing that you need to know, to solve a polynomial equation, you must make sure that the equation is equal to 0. This is not an option. You have to make sure that the equation is equal to 0. And so as we're doing this, we're going to look at 3 examples for the 3 different ways that you can solve a polynomial equation. So if you will pause, copy down this information, and I will come right back with the 3 methods that we can use. Okay, we have 3 methods for solving polynomial equations. First one is by graphing. You're going to look for the zeros or the x-intercepts. This method is preferable when you have a graphing calculator and when the problem allows you to solve it by graphing. Occasionally you'll be told that you can't use a graphing calculator, or for some reason you're not able to use it to solve it. So if it has imaginary roots, the graphing calculator would also not work. So sometimes graphing is available, and you would be looking for the zeros or the x-intercepts of the graph. Second method, factoring. You're going to break it down into its factors, and then you take each factor, set it equal to 0, and solve it. This one is preferable when your answers are real answers. They're not imaginary, and if they are whole number or fractional answers that work out nicely. Sometimes you can't factor a problem as easily as you can solve it by graphing. So this one is useful at certain methods. The third way is if you have an equation. It might have started out as a cubic or a quartic, but you've broken it down into couple of portions, and then you have a quadratic portion of the equation. You can take that quadratic portion and you can use it for the quadratic formula, which we'll talk more about in a few minutes. So copy these methods down, and then we'll come back with our first example. Okay, example number 1. We have the equation f of x is equal to 3x to the 4th plus 9x squared plus 6, and we want to solve it by graphing. So first thing we're going to do is we're going to go to our graphing calculator, and we are going to graph this function. So I'm going to pause for a moment, pull it up on the calculator, and allow you to see what I came up with. I'm actually going to change this equation real quick because this one does not have a solution. So I'm going to change this to 3x to the 4th minus 6x squared, so that we can actually have a picture that will work. So I'll be right back with a picture of the graph. Okay, so here's a picture of what the graph looks like. Now what we are looking for on our answers is we are looking for this point here and this point here. So I would then use my I would either use menu trace, or I would use menu analyze graph and zeros on my calculator to figure out what these solutions are. So I'll be right back with the actual solutions. Okay, so I accidentally forgot to circle this one in the middle here, but we ended up with 3 zeros. We have x equals negative 1.41, we have x equals 0, and we have x equals 1.41. This one right here in the middle, where it came up and it touched it and then it came back down again, this one's actually what we call a double root, or a multiplicity, because at that point, when it goes up, touches the x-axis, and then immediately comes back down again, it's tangent to the x-axis. Anytime it does that, that means that the same answer or the same factor happen twice. If you were to look at this one, notice that they have a common factor that we could factor out. It's 3x squared. And so then you're left with x squared minus 2 as the remaining part. This 3x squared, you have x times x, and each one of those x's is equal to 0, and that's why it's a double root at that point. These are the two answers. Notice that they are not whole number answers, so I would not want to finish solving this problem by factoring, but I could have used the quadratic formula. Go ahead and pause, copy down the rest of the example, and we'll move on to example 2. Okay, example 2, we want to solve 3x squared minus 5x equals 2 by factoring. Again, as I noted at the very beginning of the notes, it must be equal to 0, so our first step is we're going to subtract 2 from both sides so that we get it equal to 0. Next thing I'm going to do is rainbow to get rid of this 3 at the front. So now I'm going to have x squared minus 5x take away 6 is equal to 0. So all I did was take my 3 and move it to the end. Now I'm going to factor. So I have x and x. My factors of 6 are 1 and 6 and 2 and 3. And we want to subtract, so I need the pair that is going to subtract to give me 5, which is 1 and 6. And last but not least, I'm going to fill in my signs. My signs, since I'm subtracting, one's positive, one's negative. I need the negative 5 in the middle, so the 6 needs to be negative, the 1 needs to be positive. And now that I have filled that in, now I'm going to go back and divide by that 3 that we multiplied by. So if I divide by 3, I get 3x plus 1 and x take away 2. Now that I have completely factored it, the last thing that I'm going to do is I'm going to set each factor equal to 0 and solve it. So 3x plus 1 equals 0, x minus 2 equals 0, and now I'm going to finish solving it. So to solve, subtract 1 from both sides. 3x is equal to negative 1. And then the last step, I'm going to divide by 3. So one of my solutions is x equals negative 1/3. My second solution, add 2 to both sides. And then I'm going to be finished because 0 plus 2 is 2. I don't have anything to divide by, and so x is equal to 2. So we have found our two solutions to our original quadratic formula. I'm going to go ahead and stop the recording, and then I will put a second video up to cover quadratic equations. Make sure you watch that one as well.